the law of sines ambiguous case. So if we end up with a side-side angle situation, you can see from your decision tree that we have a problem. It says side-side angle, you follow it down, and we look at it and it says if the side opposite the angle is longer than the other given side, then we just have this one solution piece. Life is good. That's part of what we did last week, right? We saw that. But what if you end up with this? Side opposite the angle is shorter than the other given side. Then you have two problems, and that you have to know how to read this and navigate through this for the test. Okay? Your best bet is to be able to read through this as you're doing your assignment and follow along with it to know what's going on. So we try it. Let's say we have a side-side angle and the opposite leg is shorter. What happens? Draw this out. So if we have suppose we have an angle here that we know. We'll call it 30 degrees. Okay? And suppose we have a side length that we know, and we will call that 10. And then we have a side opposite the angle, we'll call 7. Is that side opposite shorter or longer than the other given side? Shorter. In that situation, it's possible that you could come up with two solutions. So as you look here, this is one triangle that has an angle of 30, a side of 10, and then a side of 7. Watch what happens if I swing the leg from that top point. Does that triangle also have an angle of 30, a side of 10, and a side of 7? Yeah, it does. So does that one. So does that one. And you don't know which one it's talking about. That's why back when you were in geometry, you couldn't use side-side angle as a congruence theorem because you don't know which triangle you're supposed to get. And so I'm going to draw one in red. That's one triangle. And then I'll draw one in blue. Those are our two triangle solutions because this leg over here swings on a pendulum and creates that other side over there. You see that? It's also possible that you can have a side opposite the angle is shorter than the other given side, and it turns out to be no solutions. So you can see this one gave us two solutions. I'll show you an example of a no solution one. I think you'll like this one. I'm drawing a dashed line because we don't know exactly how long that is. It depends on the rest of the problem. So I'll call this again an angle of say 35 degrees. We'll call this 15. Okay, and I'll create a side over here of length 2. If that's 15, everybody agree this would be about a length of 2? It doesn't exactly reach the other side, does it? It doesn't matter how you switch it, flip it around. Come on in. Doesn't matter how you flip it around. It isn't long enough to reach the other side. So you got this awkward length of 2, and it just won't reach the other side. So in that situation, we have a side that's just too short. So it says opposite leg is shorter. It's just too short. Now remember when you were solving sine before, you had like say sine of 35 over 2 is equal to sine of say b over 15. If we set that up. Remember we set those kind of problems up the other day? you always ended up with sine of B was equal to some number, say like 0.8. What did you do to solve for B? What did you do with your calculator? Sine inverse, right? Well, here's what's going to happen with this situation. You're going to get sine of B is equal to like 2.43. What's the biggest value that sine can be? 1. What's the smallest value sine can be? -1. Can sine ever be 2.43? No. Watch what happens with my calculator. If I take my calculator out and I press sine inverse of 2.43, it gets all angry at me. It says, you can't do it. It's a domain error. You press go to find where the problem is, and it doesn't like that value, 2.43. If you change it to 0.43, because sine has to be between -1 and +1, then you get 25.46. It likes that a lot better, okay? So that's an indication. So you can have 2 solutions, or you can have no solution. We have another option, okay? If the leg opposite is longer than the other given side, then there's just one solution. And that's what we dealt with the other day. So I'll draw this out again. It's my dashed line. Call this 10. We'll call this 15. Call this 40 degrees. If I draw that triangle and I extend this side over here, tell me, is the side opposite the angle longer or shorter than the other given side? Longer. 15 is longer than 10, right? Watch what happens if you swing on the pendulum. I mean, it would be, it never intersects that side, does it? Ends up being way over here. So that's why there's only one angle or one triangle that can be created. Just one solution. What we're going to practice today is we're going to practice all 3 of those examples, and you're going to understand how to navigate through the chart. So please be ready to read what's in front of you, and we'll give it a shot, okay? I start by drawing the triangle. I have angle A, angle B, and angle C. Angle A is 42 degrees. How long is this side right here? 12, because that's side B. How long is this side? 22. So anytime you're given triangles, you need to classify which case scenario it is. So look at this triangle. Which of the 6 is it? Is it an angle, 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 an angle, angle, side, an angle, side, angle, a side, side, angle, a side, angle, side, or a side, side, side? Side, side, angle. Very good, because the angle does not sit between the 2 sides. If the angle was here, then it would be side, angle, side, right? So this is a side, side, angle type of triangle. As soon as I see that, my brain has to say, uh-oh, I got a problem. Because when I look at this side, side, angle, as I follow down the decision tree, it forces me to ask some questions. You guys tell me, is the side opposite the angle longer than the other given side? Or is the side opposite the angle shorter than the other given side? Let's check it out. As you look at this, side opposite the angle is longer than the other given side. So, as I look at my decision tree, it says, if that's the case, there's just one solution. Use the law of sines. Thank goodness. Life is good, right? So, we don't have to worry about that 2 solution scenario or no solution scenario. We just set it up. Angle A, angle B, angle C, side A, side B, side C. All right, what is angle A? 42 degrees. What is side A? And what is side B? 12. And I can't write as small as you, so I'm going to end up kind of going over to this side. But what angle do I want to find now? Do I want to find angle B or angle C? Angle B, very good, because I know side B. So I'm going to say the sine of 42 over 22 is equal to the sine of B over 12. And this is where I cross multiply. I get 12 sine of 42 is equal to 22 sine of B. And then divide by 22. And I'm going to get a decimal, and I'm going to write that decimal down. I'm going to make sure I'm working in degrees. I am. I have 12 sine of 42 divided by 22. Yep. So I get 0.36498. Tell me, can sine be equal to 0.36? Is that between negative 1 and 1? Yeah, so life is good. I can figure that out. So how do I then find angle B? What do I do? Sine inverse of the answer, and I get 21.41. So angle B is 21.41 degrees. What can I now find that's easy to find? Find angle C by subtracting those from 180. I get 116.59. How do I find side C? Sine of 42 over 22. Cross multiply and divide. I get 29.40. Okay. We okay there? All right. Very good. So let's move on to our second type of problem. So was A really different from what we had done? Nope. Move on to B. Create my triangle. A, B, C. A is 85 degrees. Side A is 15. B is 25. What kind of triangle is this? It's an angle, side angle, a side, 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 side angle, side, side, side angle. What do I got? Side, side angle. And so I go to my decision tree, and it says side, side angle. And something goes off in my brain and says, oh, no. That's where I get the tricky answer. So I go down here, it says side opposite angle is longer than the other given side, or side opposite angle is shorter than the other given side. Ooh, yeah, it is. As I check this out, I look at it, it's shorter than the other given side. So we don't really have much of a choice here other than to start solving the triangle. If you look, here's what's really important, okay? We start solving the triangle, and we're either going to get no solution or we will get two solutions. Here's our key. When solving for the missing angle, if sine is less than 1, then there's two solutions. When solving for the missing angle, if sine is greater than 1, then there's no solution. We have to see whether we come up with sine greater than 1 or less than 1 before we know which scenario it is. So let's try it out. I have the sine of 85 over 15 is equal to sine of B over 25. I get 25 sine of 85 equal to 15 sine of B. Divide by 15. See what decimal I get. 25 sine of 85 divided by 15. I get 1.6603. Can sine be equal to 1.66? It can't. What's the biggest that sine could be? 1. And if you try to inverse that answer, it doesn't like it. So this is a no solution. Turns out I wasn't very accurate when I drew the triangle. If that side is 15, I probably should have drawn it like that. It's just too short to reach down to the other side. You can't make a triangle with those dimensions. What do you think the last one's going to be? 2 solutions. As you can see, we covered the 1 solution when the side opposite is longer. We did the side opposite shorter. We got sine greater than 1 no solution, and now we'll do this one. You are right. We are going to get 2 solutions. Let's see how it works out. Right? Once we do this, we're done for the day. Side A, side B, side C. 20.5 degrees, 12, 31. Side angle. Is the side opposite longer or shorter? Side opposite is shorter. As I go to my decision tree, I either have no solution or 2 solutions. How do I know? I have to start by solving for sine of theta. So let's set up our work and see what we get. I have the sine of 20.5 divided by 12 is equal to the sine of b divided by 31. I'm going to cross multiply. 31 sine of 20, 0.5 is 12 sine of b, divided by that 12, and I'll come up with a decimal. 31 sine of 20.5 divided by 12. And I get 0.9047. Can sine be equal to 0.9047? Yeah. And so it says right in the directions, and this is what you get to use on the test. If sine is less than 1, then there are 2 solutions. At this point, set up 2 triangle solutions. So I'll set up 2 triangles. We have triangle 1. We have triangle 2. A, B, C. What is angle A? 20.5. And it's that case for both triangles. What is side A? 12. And it's that case for both triangles. What is side B? It is that case for both triangles. So your givens are all the same, but everything changes after that. In the directions, it says that at this point, set up 2 possible triangle solutions. Triangle 1 will have theta be an acute angle, and triangle 2 will have theta be an obtuse angle. So let's start by finding the acute angle. We will do sine inverse of our answer. What does it mean to be acute? Less than 90. You can see we get 64.78. So I'll write that down. 64.78. Triangle 2 has theta be an obtuse angle. And the directions say to find theta, do sine inverse, which is what we did. To find the obtuse angle, take 180 minus theta. So I'm going to do 180 minus that 64.78, and I get 115.22. What does it mean to be obtuse? You can see I have an obtuse angle. 115.22. So you can see that when you solve for that first angle, that's where you really set stuff up, okay? That's where you change things. Now, can we find angle C right here? How? Yeah, subtract from 180. So 180 minus 20.5 minus 64.78. I get 94.72. And then for the other one, I'll do 180 minus 115.22 minus 20.5. I get 44.28. So those aren't the same, are they? How do you think we find side C for each one? We are going to do our law of sines. Sine of 20.5 divided by 12 equals sine of 94.72 divided by C. You get 34.15. Then for the next one, I'll set up the same thing. Sine of 20.5 over 12 equals sine of 44.28 over C. So, here's the trick, you guys. On the test, I don't tell you ahead of time what you're going to come up with. I just give you pieces to a triangle. What you have to do is you have to look and see which scenario do you get, and then follow the right path. The good news is that we'll practice a lot. The other good news is that you get this on the test. Bad news is that it's still not always easy. You really got to follow through. Okay? So, here's what I need you to do. I'm going to put an assignment on the board, and you get tomorrow in class to work on as well, but I'm not going to be there to help you. So, it might be helpful to rewatch the video during your time as well. Fair enough? Okay. If you could get this lesson, you could get an A on this test. Okay? This is the hardest lesson. Look, there's your assignment. I think that there's 1 no solution, 2 solutions, and 3 1 solution. Then you have tomorrow to work on in class.